In this video, we'll start looking at stoichiometry, our calculations that we do in chemistry. This is the first part of our stoichiometry. So when we look at stoichiometry, what that really means is we're doing unit conversions. We saw unit conversions in the beginning when we were converting between different random units like seconds to hours, or years to centuries, or millimeters into kilometers. You're able to practice doing those sorts of unit conversions. So now we're going to take it a step further and start converting our chemistry units. And here's a nice flow chart for converting our chemistry. We're going to start today by looking at first how we convert between atoms or molecules into moles. And then we're also going to be looking at how we calculate from moles into mass. So we're going to be doing these two steps today. So by the end, you should be able to go from atoms all the way to mass, or from mass all the way back to atoms. In our next video about stoichiometry, we'll cover the rest of the table here. This first part, we're going to learn about how to convert between atoms or molecules into moles. Now for that, we're going to be using Avogadro's number. We previously learned about Avogadro's number. If you remember, it's 6.022 times 10 to the 23rd of something, anything. So we can say it's atoms per mole. So it tells us how many of those things there are per mole. If you remember, I kept calling it the chemist's dozen because we use it all the time for conversions between atoms or molecules to moles. And so when we look at a problem, let's say we want to figure out how many atoms there are and 3.5 moles of helium. So for that, we want to go between moles to atoms. So we know we have to use Avogadro's numbers because we're going into atoms. We're going from moles to atoms. So when we set this up, we want to make sure the 3.5 moles and the unit of moles cancel out. So we'll put Avogadro's number on the top for atoms and the per mole on the bottom. Which leads us to having 3.5 moles of helium times 6.022 times 10 to the 23rd helium atoms per mole. And you can see the moles cancel out. The units of moles cancel out. This leaves us with 2.1 times 10 to the 24th helium atoms. And if we remember for our significant figures, whatever number we start with, so this one has two significant figures in it, is the amount we end with. So our answer should only have two significant figures. So not too bad, right? When you go between moles and atoms, you would multiply. If you go from atoms to moles, then you would divide. So now we see when we've gone from moles to atoms, we multiplied by Avogadro's number. And then if we were to do the opposite one, we'd have to do the opposite operation. So we'd have to divide by Avogadro's number. But we'd still use Avogadro's number as our conversion factor between atoms or molecules and moles. So now we'll do the second part where we go between moles to mass. And for that, we'll have to use the molar mass as a conversion factor. And remember, the units for molar mass is grams per mole. So you can still see the mole is part of our unit here. Looking a little closer at the molar mass of a substance is the mass per mole of its entities, whether it's atoms, molecules, formula units, doesn't matter. And then the mass in grams of 1 mole of atoms or that compound equals its molar mass, it's grams per mole. And one important thing, remember on the periodic table, whenever we had our periodic table, say we're looking at hydrogen, remember this number down here, that was our atomic mass units. That told us how much one atom weighed in atomic mass units. That number is also its molar mass. It's grams per mole. So remember, atomic mass units, we're looking at the weight of an individual atom. And molar mass, we're looking at kind of more the laboratory scale. And if we remember they came about by similar ideas. They both came about by using carbon-12 as a standard. So that's how we can have the same number on the bottom here for atomic mass units and grams per mole. So that means one atom of copper has an atomic weight of 63.55 atomic mass units. It also means that 1 mole of copper has a mass of 63.55 grams. So this number here, we can think of it as either atomic mass units when we look at individual atoms, or grams per mole, the molar mass, when we look at a large amount of atoms, when we look at what we'd measure out in the lab. So this means the molar mass for elements is the atomic mass unit. They're equal to each other. So if you look at neon on the periodic table, it's 20.18 atomic mass units. It's also 20.18 grams per mole. And then if we look at oxygen, you may be looking at your periodic table and saying, hey, it's 16. Why is she writing 32? Remember, oxygen is one of our diatomic elements. So when oxygen is in its elemental form, it's actually O2. So that means I'd have 16 plus 16. That's how we get the 32 grams per mole. We have to add the mass of each oxygen together. So this means also for compounds, the mass in atomic mass units of one molecule is going to be the same as 1 gram per mole, 1 molar mass. So we'd add the weight of each atom together to get the molar mass. So examples, sulfur dioxide is the weight of 1 sulfur plus 2 oxygens. And that would give me about 62 grams per mole. Because if you look at your periodic table, each sulfur is about 32, and then each oxygen, as we saw, was 16. So 32 plus 16 equals 64 grams per mole. So this way we can have the mole lets us relate the number of a substance to the mass. So this way I know I can figure out how many atoms are actually reacting by just weighing out the mass. And we weigh out the mass of it in the lab on a bench scale, usually in grams. So that's why we care about this so much. We always weigh things out in grams when you look in the laboratory. It's very difficult to weigh out one atom or just a couple atoms at a time. Instead, you may be asked to weigh 5 grams of a sample. You should be able to figure out how many moles are in that 5 grams. And if you know the molar mass of the compound, you can figure it out. So now let's look at an example. If I want to figure out how many moles are in 0.58 grams of carbon. First step, I know I'm going from carbon into moles. Moles is my desired unit. So looking at how to solve it, going from grams to moles, I would use the molar mass. I'd have the moles on top and the grams on the bottom. So we divide by the molar mass. When we do that, we get 5.8 grams of carbon, and the carbon on the bottom cancels out, leaving us in just moles. So it's 0.58 divided by 12.01. This gives us 4.8 times 10 to the negative second. If we want to go from moles into grams, then we would multiply it. So if I want to go this way, I'd multiply. If I want to go this way, that's when you're going to divide. So now if we want to add a little more information in here, when we go from moles to mass, that's when we'd multiply by the molar mass. If I wanted to go from mass to moles, that's when I would divide. So now our last step that we're going to be doing today is connecting these two together. You can see moles is our common unit here. So what I want to be able to do is go from atoms into mass, or from mass into atoms, which means we're going to have to do more than one step. There'll be one step to go from mass to moles. We just saw that. And then there'll be a second step to go from moles into atoms. Now you've done multiple step conversions in the beginning. Hopefully you remember how to do that. So now if I take that 5.8 grams of carbon, I want to know how many atoms are present in that 5.8 grams now. So this means I need to be able to go from grams into atoms. And if we want to kind of map it out a little bit, we know we go from grams to moles. I can't go directly from grams to atoms. So we can't do a direct conversion. That doesn't work. Instead, we got to do our multiple steps. So I can go from grams to moles, and then I can go from moles to atoms. So I can use the molar mass here, and then I can use the Avogadro's number here. Which means when we write it all out, you get 0.58 grams of carbon, divide by the molar mass, then I'd multiply by Avogadro's number to give me 2.9 times 10 to the 22nd carbon atoms. So you can see our grams will cancel out first, and then our moles cancel out, leaving just the atoms. Not too bad, right? We've done multiple step conversions. This is just the same thing. So now you guys should be able to easily go between atoms and molecules into moles. Once you're in moles, then you can go to mass. And you should be able to go back and forth between these three units right now. Remember, the key thing is you should be able to convert anything into moles. If you're unsure of what you're doing, convert to moles. So when in doubt, convert to moles. And in our next stoichiometry video, we'll look at going between all of these right here. So by the end, you should be able to go between any one of these two boxes.